What's up, everybody? This is optimization practice problem number 2. Okay, so let us get right into it. This is another 7-mark question. It says a cylinder closed at both ends is to have a volume of 2000. Oh, that is too big. Is to have a volume of 2000. Is to have a volume of 2000 pi meters cubed. What should its dimensions be if the surface area of the cylinder is to be as small as possible? So, we're going to start by listing the variables, what we have, right? We have the volume of the cylinder, which is 2000 pi meters cubed, okay? And we know that the volume of a cylinder is pi r squared h, okay? So what we can do here, we can substitute this 200 pi into this formula, pi r squared h. And then we can see there is a common variable, which is pi. So what we can do is we can divide by pi, okay, so that these two can cancel. Then we're left with 2000 is equal to r squared h. Now, I want us to divide by r squared so that h remains, okay? So h is equal to 2000 divided by r squared, okay? And then we're going to list this as equation number 1. Okay, now let's carry on. What should its dimensions be if the surface area, okay, so we'll want the surface area of the cylinder is to be as small as possible. So they want the minimum value, okay? So we know okay, let's carry on here. We know the surface area of a cylinder is 2 pi r h plus 2 pi r squared, okay? So since we have the value of h, okay, we can substitute this h into the surface area formula, okay? So that will be equal to 2 pi r multiplied by 2000 times r, 2000 over r squared, okay, plus 2 pi r squared, okay? Then we can simplify further, bring this 2 pi r squared to the numerator. We're going to say 2 pi r multiplied by 2000, all of that over r squared, plus 2 pi r squared. Alrighty, so we're going to simplify further. We're going to say, okay, so we can cancel 1 r, okay? So we're going to be left with 4000 pi. So it's going to be 4000 pi over r. Okay, so we cancelled, what we did here was cancel these 2 r's. So here there's only 1 r that's remaining, and the number that's remaining here is 2 pi. Okay, and then we took this 2 and multiplied it with 2000, and it gets us 4000 pi. Okay, so that's why it's 4000 over r. And then there's nothing to simplify over there, so we leave it as 2 pi r squared. Okay, I want to say over 1 because we will want to find the common denominator. So the lowest common denominator, the LCD. So the LCD here, the LCD is going to be equal to r. So which means that we'll need to multiply by r here and multiply by r here. Okay, so it's going to be 4000 over r 4,000 pi, over r plus 2 pi r cubed, 2 pi r cubed over r. Okay, now since we have a common denominator, we are going to bring the terms together. Okay, we don't need to. Yeah, we don't need to. Let us, I want to bring these common denominators to the numerator. Okay, so we're going to say 4,000 pi r to the power of negative 1. Okay, so we brought this r to the numerator plus 2 pi r cubed times r to the power of negative 1. Okay, then we'll need to simplify further by saying 4,000 pi r to the power of negative 1 plus 2 pi, and you can see we need to simplify here. So multiplying the same base, we're adding exponents. So we're going to say r to the power of 3 plus minus 1, right? And that will give us r squared. So it's going to be 2 pi r squared. Okay, and then we're going to need to find the first derivative of the surface area. Okay, that'll be negative 4,000 pi r to the power of negative 2 plus 4 pi r. Okay, and we know that the first derivative is always equal to 0. Therefore, 4,000 pi r to the power of negative 2 plus 4 pi r, that is equal to 0. Okay, now that we found the first derivative, we can bring this r squared back to the denominator. Okay, so it's going to be, okay, let's keep it. Hold on, I did a mistake. This is negative 4,000. Okay, let's keep it and see what happens. 4 pi, so it's going to be 4 pi r is equal to 4,000 pi r to the power of negative 1, negative 2. Okay, and then we're going to divide by 4 pi. Divide by 4 pi. And then it's going to be r is equal to 4,000 r to the power of negative 2. And then we're going to divide by r to the power of negative 2. Divide here by r to the power of negative 2. Divide by r to the power of negative 2. And then we're going to be left with 4,000 is equal to r to the power of 1 minus negative 2. And 4,000 will be equal to r to the power of 3. And we'll have to cube root both sides. Cube root both sides. And therefore we'll get r as... Hold up. I'm making another mistake. This 4,000 pi r squared divided by 4 pi is going to give us 1,000, not 4,000. 1,000 r to the power of negative 2. Okay, and then that means we're going to have to change this into 1,000 and 1,000. And we're going to change this into 1,000. Okay. Forgive me. This is my first time doing it. So make a bit more mistakes. Okay, so R will therefore equal to 10. R will therefore equal to 10. So since we found R, which is one dimension, we'll need to find height, which is the other dimension. And we found a formula. We have the formula for the height, which is 2000 over R squared. So it's going to be 2000 over 10 squared. And that will equal to, let me check in the calculator. That will equal to 20 meters. And therefore, we have our dimensions.